Hey guys, welcome back. In the previous video, we saw how to deal with assertions. So with this, we also have addressed this part of handling assertions. And as we saw, we have a specific class for asserting things like status code, which would be relevant for all the API endpoints, irrespective of what kind of response they provide. And we have specific classes for handling the JSON response, which of course depends on the API endpoint that we are validating. So verify response contains all the common code for asserting things like status code, contains value, and in the future, like it will also contain code for validating JSON schema validations, right? And then we have specific classes for validating response body of different endpoints, like for booking, customers, hotels, etc., etc. So in terms of optimization, it looks like a nice optimization that we don't have any code duplication going on here. But when we look into, for example, tests, it still looks a little bit odd to have two calls to assert common information and to assert specific information. And of course, we also see a bit of a code duplication in terms of assert all method and assert that method that captures the response. And wouldn't it be nice that instead of having two methods, if we just have one method which says, hey, verify booking response, assert that response status code is this, it has booking this, assert all, of course without doing any code duplication. So in this video, that is exactly what we will try to achieve. Now, one thing that you can think right away is like the way we can inherit all these things from this base class into our child class is if we just extend verify response class to verify booking response. And it might also make perfect sense because extends from an inheritance perspective, verifying a booking response is a type of a verify response, right? So it makes perfect sense. And as we can see, for example, in this class, response and soft assertions are already available. So maybe we can comment this code out. It is not able to access response and soft assertions. It's because they have private access in the verify response class. So let's go back and change it. So let's see if I can make it protected. Let's do the same for this. So if we come back here, now both of them are changed from private to protected, right? Let's see what else it is complaining. And then of course we don't have to initialize these fields now in this class, but we can initialize them in the base class, right? So we can pass the response to the base class, and in here we should be able to initialize the response to response and soft assertions as new soft assertions. I think the reason we are still getting error is because this has private access and it needs to be protected. So let's see if I make it, if I copy this, make this protected as well, then the errors are gone, right? And of course, we don't want to initialize it here. The initialization should happen in the parent class. We will still like to capture the response from this child class because that would be our entry point. So let's keep this method, and in fact we can comment this method because we already have this method covered in the main class, right? And what else? So these are specific methods for this class, and of course we don't need assert all. So let's also comment this because we have an assert all in the base class, right? So this looks okay. Why is it complaining? So let's go back to our test and see what's going on here. Verify response. Of course, we have a lot of verify response assert that methods that we have now commented, and all of them are now failing. So what we will do is, for now, I will just go ahead and comment all these methods. Comment all these methods, comment it, and comment it, right? And what I'm going to do is in our test where we have these two calls, I will now try to do both the assertion of specific response type and the status code both in the same class. So now if I do a dot, I can actually see the status code method available here, right? The thing is, it is not returning us verify booking response class. So if I select this, then I will not be able to get back any other method for this particular class. Let's just try it out and see, what I mean by it. So if I say sc okay, you see now if I do a dot, I can only now get the methods which are a part of the parent class, right? So I can access the parent class common methods, but now I'm not able to access the child class method. So this is not working as we expect. One workaround that you can do is you can say, hey, why not let's first do all the specific methods here, and keep all the methods that are for parent class in the end, and that would work. It would work. It will have its own challenges, but it should work. So let's say if I try to run the class now. So it seems like a simple solution, right? Like you just extend the class. Now you've got all the methods available. You can extend specific things first, and then you can extend all the things which are common in the end. On paper, it seems like a good solution, but I will tell you why it is not a good solution. The problem is, if we go to status code, you actually want to first assert that the status code is okay or not. Like imagine if the status code was not okay, and let's say if it gave you a 4 not 4, you are trying to assert something in the response which doesn't even exist, right? And that is the reason that status code is the first thing that you should try to assert, and only when it is okay, then you should try to go ahead and assert other things. That is also the reason, by the way, why, for example, the has booking method is using soft assertions, because it is completely okay that in the JSON response, if you have 10 fields, one field fails but the other field is as expected. But it is completely not okay to try to assert something once the response code is not as per what you expect. And that is also the reason why the assertion on status code is not a soft assertion, but it's a hard assertion. And what we mean by that is, once status code method fails, if you have 4 or 5 more methods to test any other functionality, those methods will not be run, and the test will stop at the very first hard assertion, right? So from that perspective, ideally what should have happened is, first we should have a method for status code, and then we should have a method for booking. And then of course we know that if we try to do this, this does not work. So what we mean by this is, this solution is not going to work for us, in terms of meeting our testing needs. So we have to look for a new solution. And the way we can solve it is, and I would like to give credit to one of my colleagues, Kasia, who has implemented a similar solution in another project, and which became an inspiration for me to also apply it in the case of APIs, to be able to return as an object type which is also of the child type. So the way you can implement it is, if I go back to verify booking response class, instead of making this verify response class as a normal class type, we will convert it into an abstract class type, right? And what we will do, we'll also specify a type which will take either the parent type or the child type. So what I mean by that is, let's say if we create a new field and we call it as self type, and let's call it as self type. At this moment, this field does not exist, right? So what I need to do is, I have to say, in this class, I want to define a new type which is called as self type, right? And the moment I define this type in this class, now this error is gone. And I'm saying this self type should actually extend either something, a class of its own type. So let's say verify response, or it should extend any other class which is of a type verify response. So basically any class that extends verify response is a valid candidate for this self type. And then what we will also do is, instead of just accepting a response type as an input, we will take another input of class type of self type. And what we will do, so let me put a comma here. So we will take self type, right? And we will initialize the object instance with the self type here. So let's say if I say this self type is equals to self type, and if I cast this instance to its own type, you would be able to do method chaining. And by the way, if all of this looks pretty confusing, well, it is pretty confusing, because like the concept of generics and abstract classes with Java is not very intuitive. But what is important for you to understand is, once we make this little change, you will be able to do method chaining even when you are inside the parent class, and that is what is important for you to know for this moment, right? So that this is all the change that we need to create here. And in the verify booking response, what we need to do is we need to basically extend the not just the base class, but we basically want to extend itself, right? So we're saying extend itself in this particular class. And once you do that, you will be able to now access the parent methods as if they were methods from the child class. Now, one more thing that you need to do is you have to now initialize two things, so not just response, but you also have to provide the name of the class. And the name of the class is verify booking response. So let's put a comma here, and you need to provide this particular class so that this instance can be converted to itself in the parent class. Anything else? Let's see. I think that is all that we need to fix here. Cool. So what else do we need to do? I think another thing that we need to do is, instead of all these methods returning verify response, we need to now return the self type. So we need to return the self type itself. So if we say return self type, and not here, we should say it self type, then we should be able to do method chaining. So not return this, but return self type, right? So I think that's all the change that we need to do. And now if we go back to our test class, instead of doing status code is okay here, you should now be able to do status code is, and now if you see, it is returning the same child type as the return code. And now you know that because it is returning the child type, it has got all the methods available, right? Has booking ID, has booking, post has booking, and it also has got all the methods available from the parent class, like assert all, status code, contains value, etc., etc. So let's put this one before, and let's change, let's remove this line, and let's run the test again and see if it is working fine or not. Cool. So the test is green, right? So let's say if I copy the whole thing, and let's also try to demonstrate a difference between hard asserts and soft asserts in this. So if I go up in the setup method, what we can do is, if I want to assert status code, has booking ID, and all those things in one method, are we able to do it or not? So let me comment this. Let me also comment this, and let's run the test. So let's say if I run this test, this should be green, but what I will demonstrate is, then we will change the status code to not okay, and then let's see if it still works fine or not. Cool. So the test is green, and if I change this to it as not found for not for, then nothing should, like, it should stop here and it should not run these two methods. So let's just go back and run this test again. Cool. And if you look into the assert, if you scroll down, in terms of failures, it is only showing us one failure, that expected 4 not 4, actual was 200, and it stopped here. To give another example, that if this was the case for soft assertions, the test would have still continued. Let's change this back to SC okay, right? And let's give a invalid booking ID, right? And in fact, it expects a value as long. So let me give any long number here, right? So this will fail, and it will still test for post as booking. And if it is okay, this will be okay, and only this particular part will fail. And in fact, just to demonstrate that it will test all the failing things. So let's say if I change this booking to booking set booking dot set first name, and if I just change the name, then we know that we will have two failures, right? Because we can see that the booking that we have sent in the input is different than the booking that we are setting for assertion. So basically both these should fail, but we want to see that it does not stop at the first failure, and it should basically run all the failures. So let's run the test. So if you look into the test is failed, which is what we expected. We expect two failures. One is about the the booking ID, which is incorrect, right? And the other should be about the booking detail. And as you can see, we gave as an input Jim, but we changed it later to blah. And that's the reason we are getting both the failures. So it did not stop at the first failure. With soft assertions, it actually ran all the failures, which is exactly what we want, right? So I think with this, I can conclude this video. I will do all the cleaning up and remove all this code, which is not necessary anymore. So for example, if I remove this, I can also remove this. Let's keep the booking ID as booking ID. We're not changing the booking body. So now we have just one assertion, for the whole thing. And let's see. In fact, we don't have to check for the booking ID. Let's just put it in the arrange act. In fact, let's do assert here, and we can set the booking ID if everything was okay, and we can copy paste the whole thing in all the methods. I'll do the cleaning up later, but for now I think it's sufficient to conclude that now we can have Fluent method chaining, and we don't need two methods, one for status code and one for asserting the booking body. So that's it, and we'll look for another interesting topic in the next video. See you. Cheers. Bye-bye.